Hello, my name is Aiden Arabzadeh, and this is project 2.6.2, the real-time clock RTC prototype. Here is my working breadboarded circuit, and this is the final encased product. The purpose is to use the concepts of persistence of vision, POV, wire communication, and 4-digit 7-segment common anode displays to get and store the current time and date and display them. How this works is the DS1307 breakout board stores the time, which is taken in the code and broken down into digits, which are transferred onto the 4-digit display via the shift registers. Let's talk about how 4-digit common anode displays work to get a better understanding. In reality, only one digit of the 4 7-segment display is on at once. This is why we need POV. 4 pins on the display are reserved for each digit, connecting to the power side of all the LEDs, hence the common anode in the name. These 4 pins are controlled by the collectors of 4 PNP transistors, with the base pins connected to the first 4 outputs of the second 595 labeled the anode 595, and the emitters connected to power. To control the segments individually after one digit is enabled, the respective pin for each segment is pulled low, A to G, and these 7 pins are controlled by the first 595, labeled the cathode 595. Now let's jump into the code. Alright, so here's my code. The purpose is to get the time and date using macros and shift them out onto a 4-digit 7-segment common anode display, alternating every few seconds. The loop is separated in 3 parts: getting the time and date, showing the time, and showing the date. For the setup, we have set time date, and this writes the time and date data to the RTC. This scanf function reads the time data from the macro and stores in the format outlined here, and this one reads the date data and stores it in this format. The month here, this is stored as a character value, but the date, hours, and all these other ones are stored as regular integers. Here I tried to convert the letters to integer values by using the ASCII code, but it didn't end up working. However, it still displays the correct month, but if the month changed, it's not going to work and update. Here I just write the time and date data to each respective register, and now we're on to the get time date. Okay, so first I'm going to start reading from register 1, and I want 6 bytes, so that's what I'm requesting. And then I read the time and date data. In this section, we set the buffers to the 1s and 10s digit of hours and minutes, and this is in the form of the cathode pins, which we need to alter to display the integer. If it's March, which is the 3rd month, it's going to set the first 2 slots in the date buffer to the letters M and R. So it goes here and it finds what it needs to shift out to display the numbers on each digit. And now I finally get to show the time. So this just determines the duration that it's displayed for, and this for loop shifts out a digit of the time, just one at a time, depending on the cycle of the for loop. For example, if we're on digit 0, it will shift out a bitwise anode 1 onto the anode 595, which will go into the base pins of the transistors. The collectors of the PNPs are connected to the 4 anode pins, and whichever one's high, in this case digit 1, will be enabled. Then the time data for that digit is shifted out onto the cathode pins to turn on the correct segments and show the number. And I do the same thing here with show date. I think for now that about wraps it up, and I hope you learned something about the RTC or real-time clock prototype and how it all works.